everyone. Thank you for joining us. So today I'm going to present our lightweighted HDFS disaster recovery. So we want to share these ideas to you. It's actually an open source project. We put it online maybe a year ago. And currently it's a prototype, but we hope people can follow up and join us. So allow me to make a brief introduction about Intel and myself. People's asking me about why I'm here. So actually Intel do more than hardware. We sell chips, we sell hard drivers, FPGAs, but we also made software. We make contribution to open source community, we make contribution to Linux kernels, and you can check more details in these links. And for me, my name is Qiyuan Gong, and I'm a software engineering from Intel's Open Source Technology Center. So we make contribution to open source projects. And a year ago, I worked on deep learning on Hadoop. We want to enable TensorFlow, MXNet, and maybe cafes on Hadoop Yarn. But at that time, we have a very painful experience because, well, Yarn didn't support Docker at that time, so our project is finally canceled. And now we are working on smart storage management for big data. We provide a open source project that can collect a lot of metrics and handle data movement between ties, small files, and also our disaster recovery is one of its components. So I own a PhD degree in data anonymization. It's related to GDPR. I heard a lot of people are talking about it. So you can email me if you have questions. So I think people here know pretty much about HDFS. It's a main component of Hadoop, and it's a very important part of Hadoop ecosystems. Actually, we have a lot of choice for resource management. For example, we have Kubernetes, main source, and we don't have too much choice about file systems. So why do we need disaster recovery for HDFS? Because we cannot afford the lost data. But actually, HDFS can make data replications. He can, at least we put a file on HDFS, we have 3 replications. And we sometimes lose some hard drivers, lose some servers, even a rack. That will not hurt HDFS. In most cases, we don't lose the files. But if you lost a data center, we lost everything. So actually, disaster recovery is more than backups. So first, you need to have multiple data centers. So some bad things happen, you will not lose your state. And then it's backup. You cannot lose state. Lose state is very expensive. Amazon's proved it maybe a few months ago. And we should keep our service high availability. We should switch to another data center when we lose one of them. Also, performance is important. Resource usage is important. We cannot afford that disaster recovery. Use all our resources. But today, let's focus on backup first. So I'll try to make it simple. Actually, disaster recovery is very boring and have a lot of tricks. So first, we need to make an entire backup. No tricks, just copy the files on your primary cluster to your remote cluster, just like you clone a project from GitHub, and then we make incremental backup on it. So the tricks come from the incremental backup, how to detect the changes and apply it to remote. And for entire backup, for the first backup, they're only about compression to reduce traffic and encryption to enable security. So I quite like this incremental backup because it's quite like our vision control. We are engineer. We use vision control like Git. So when we have a vision on base visions on our servers, we apply changes to it. So actually, there are 2 important parts, how to find the changes. then how to apply it to remote. And the key point is you need to find very precise changes. Not just this file is changed. You need to get detailed information about that. So how many content is changed? Is that metadata is changed, group changed, or replication is changed? And we need to handle about performance, resource usage. Bandwidth between data center is very limited. We cannot use all of them. Also, well, we sometimes get corner cases, just like we merge something into our local code base, then we got conflict, something goes wrong, we need to handle it. So I think people may be familiar with DistCp, also named as DistCopies. Well, it's built in Hadoop and enhanced by Cloudera and Hortonworks. So actually, DistCp does quite great jobs. It tracks changes with Snapshot, and actually it uses Snapshot report for detailed changes, incremental. So, and Snapshot is just like a reference to blocks. So even the file does not exist, you delete that blocks. If you have a snapshot, you still can refer it or copy it. Actually, DistCp copies snapshot to remote, not the actual files. So your copy will be success because you just use the reference. And DistCp apply changes to remote with MapReduce, and it runs very high concurrency in block level, not in file level. So DistCp will break the file down into block level and copies them at the same time to remote, then merge it to a very large file. So actually, it do more than we expected. So it will not copy files, is deleted. He will make namespace changes immediately and only copies changed content to remote. But yeah, here's big but here, so it's not perfect. Snapshot is not perfect, DistCp is not perfect. You cannot take snapshot in the root directory, which means you cannot back up the whole cluster with one click. And no details, because he only track, create, delete, rename, and tell you that some file is modified. You need to get a detailed check about that. You need to compare the file in block level with checksum length and find out which was changed. And it also has a lot of corner changes, corner cases. So at least some of them in the right, you can check for details. So in one word, if you have a lot of operations on the same file, if you change the namespace, you will have corner cases. DistCp, no. So snapshot just give you a wrong report about that. You need to handle it case by case. Actually, DistCp is handle it, but not do well jobs. So another problem is that MapReduce is too heavy in most cases. So especially for incremental backup, you have a very small append on existing files. Then DistCp will launch a container with 1 GB memories for it. And it costs a lot of launching time. Also, for failed tasks, for snapshot, you need an administrator to manage it. And no resource controls, no bandwidth controls, sometimes just use up all your resources. So we want to do something different from DistCp. So also, actually, we discussed with our customers about that, and we found some key pain point. We want to serve some of them. So first, we didn't use snapshot. We used logs. Actually, we use Inotify. It's a subset of edit log. We called it log post-processing. So we can change more detailed changes with this Inotify or edit log. We can track metadata changes. So you change a group, we get event. You close the file, you append very small content to that file, we got event. And also for truncate, for other operations, we also have event for that. That's more detailed than Snapshot. And the painful thing is you need to build a lineage for it, not just the event works. You need to build a lineage like our write pictures. You need to merge them together, so such that you can track the whole lifetime of a single file and make sure all your action is correct. With this post-processing, we can track event, check files lifetime, and translate this event to a actually copy event or copy task. We can actually translate an append to a copy some pieces from primary to remote. And we just delete remote files. And we didn't use MapReduce. If you attend previous sessions, you may have known that some companies, they don't use MapReduce. They have HDFS, Kubernetes, Sparks, but no HDFS, no MapReduce. So we didn't rely on MapReduce. We built several long-running services with server and agents. All these services can run in containers. So maybe you just need to launch a few, maybe 10 containers for that. Each of them requires very limited resources. And for server, we track changes, we schedule tasks. We also control the resource usage band-wise. So it's auto scale. And for agents, we just run tasks and apply changes to remote. So we have a lot of advantages. For diff detection, we are nearly real time. We get event in second. Actually, it's microsecond. Then we can decide what to do, to copy it immediately or to merge it together and make a full copy. And we get more details about Snapshot and more magic. We can merge this diff and do one thing. For example, we have a lot of append, and we can merge it together and copy it in block level. And sometimes you have a lot of operations, you append it, you delete it, and if you delete this file, that means this file is not needed to copy it to remote. So we also have very limited impact to NameNode, to your existing services. If you use Inotify, we have only very limited impact. We require some resources from NameNode. If you use edit log, you just copy edit log from shared storage. If you have a high availability, you have a standby NameNode. So with our long-running service, we are lightweighted for your data center. We only require very limited resources, and we are auto scale. We have bandwidth control. Also, we can also run in containers. But yeah, we have advantage. We also have some pain point. Actually, we have corner cases, and we don't have locality. So for corner cases, it's very painful. So we get event from edit logs, but when you try to append these changes to remote, you have found that things goes wrong. For example, you have several append and a rename. Yes, that's usually caused by that put command, HDFS put. You put a file, it just put a file with a postfix copying. Then if the file's content is put to HDFS, rename it to the true names. So it have append, rename. And yeah, if we don't do anything, we just apply an event according to its sequence, your got file don't exist, because when you got that event, got that rename event, rename has happened, and that file is not exist. So that temporary file is not exist in HDFS. If you are trying to read this file, when you want to copy the temporary file to remote. So we need to handle this. So correct way to handle this is make a merge when rename happened. You make it, you place it to the front, so you just rename the file. If the file did exist in your storage, remote storage, then you append new content to your new files. So that's one of the cases. There are a lot of cases mainly caused by rename. Yeah, so actually we cannot handle it case by case. For general case like rename, we handle it. For some small cases, we just let the task fails. Then we make a direct compare about remote file and the primary files, local files, and make a copy. And for locality, actually, we can place our agent near to your data node. And also, if you have a very high-speed network, that may be not a problem. So actually, our disaster recovery is a sub-module of smart storage management. Smart storage management provides you ability to handle move file between storage tiles. Also, it gives administrator some ability to check your status. So actually, in SSM's views, we call it SSM for short. Disaster recovery is one of its modules. So we use SSM's existing modules. We use its edit logs, auditing modules, so we can make our job very, very quickly. We write only a few code about that. So with SSM, we have rules. Administrator write rules, then SSM check if this rules is triggered, then make some actions. So you can write rules such like, for code files, we just move to HDD. For hot files, we can move it to SSD or memories. Also, we can do more than that. If you are using our smart client, we override the DFS client. So with this smart client, you can do high availability in disaster recovery. Also, we can manage your small file problems. We can compact its small files, and for users, it's transparent. You don't know this small file is compacted. So we make an evaluation about our disaster recovery. So we build two clusters with a few nodes. We place our server and agents. We run some tasks. We copy a lot of files to remote from one cluster to another cluster. So for small files, we found that our disaster recovery is 90% better than DistCp, and it used 46% CPUs less and 41 less memories. For large files, we are 11% better than DistCp, and we use 26 less CPUs and 46 less memories. So we still have some time, so I will show you demos. So here's a real examples. So for our disaster recovery, our administrator only need to write rules. For example, For example, we want to back up files in source 1, all files in source 1 to remote cluster destination 1, and check the interval is 500 milliseconds. So SSM will do the rest job. Also, you can filter your files, and maybe you just need to copy the task files. Let me check. Oh, how can I open my? Well,
what do you want to do?
Demo.
Oh, okay.
Oh, yeah. Is that one?
Where?
Yeah. Where do you place it?
This? Yeah.
Well, actually, we generated some file with DFS-IO test. Yeah, DFS-IO is a throughput test for HDFS, and it generates some temp files on HDFS. We use these temp files. So, well, let's speed up. So when we finish, we have 100 files. And we add rules in our web page. It's pretty simple. You just use it like a notebook, and you enable these rules. Well, then SSML gets the job done. Yeah, all files copied in a few seconds. OK, I will go back for details. So, oh no. So you can, oh, not copied. Yeah, all files copied, 100% finished. So we can check details about our copy actions to check if there are some failures, there are any exceptions about that. And if this rule is still working, so our disaster recovery is still watching that directory. So if we made changes to the source directory in our primary cluster, our disaster recovery will apply these changes to remote. So I think they maybe want to remove some files. Well, we remove several files, five files. It was applied to remote immediately. So we have 105 tasks that already be done, and the new tasks are caused by the delete actions. So that's it. So any questions?
Thank you for the presentation. It's very nice. How do you deal with clusters where different files or folders are moved by different
Permissions, yeah. Actually, permissions can be get from the edit log. Yeah, we just sync the permissions to remote. So the permission is ensured. So in your standby cluster, they have the same permission. So when you make a switch, your service didn't go down. People will not access some files they didn't own.
What about things like range or century?
Sorry?
There's things like Apache Ranger and Apache Century. Like the permissions and file on top of
Oh, OK. You mean that some permissions on top of HDFS?
Yeah, so Century and Ranger are
Yeah. Actually, for that, you need to handle it by yourself. Actually, we only handle the permissions is visible to HDFS. Yeah. For all permissions on HDFS, we make sure it's the same in your primary and standby cluster. For permissions we cannot find, cannot visible, we cannot do that. Yeah. Okay.
Were you happy with the HDFS use case, or did you have requirements for high HBase?
Oh. Yeah. Actually, we've made some tests on HBase or else, HHive and else, and actually, it's pretty fun. So on HDFS view, these projects are built on HDFS. We only care about files. So you make changes, we make these changes to remote. So that's will not hurt existing services. So existing service works correct, and there are changes just copy to remote. We make some, we have some report about that, but I didn't show that. So currently we are only a prototype. In prototype level, we have a long gap between productions. So I just want to share our ideas about that. Did I answer your questions? Well, actually, we are run out of hand. We are only a few people who can do this project. So we make it open source so people can follow up and join us. Okay. Yeah. Yeah, we actually have that modules. We can back up files from HDFS to object storage. We use S3 APIs, object storage, Everspan or West Digits product. That's fine. And we truncate the files to 0 length, so files are visible in HDFS, and its content is moved to object storage. But that feature is not finished. But actually, Microsoft has a similar solution for that, and it's merged to trunk. It's one step ahead of us. Yeah. Any questions? Yeah. If you don't have any further questions, contact us if you have or raise issues. So we will working on it. Thank you, guys. Thank you, everyone.